Hello, in this video, we will introduce pointers and dynamic memory management. Pointer variables are also known as pointers. You can use a pointer to reference the address of an array, an object, or any variable. Pointer is one of the most powerful features in C++. It is the heart and soul of the C++ programming language. Many of the C++ language features and libraries are built using pointers. To see why pointers are needed, let us consider writing a program that processes an unspecified number of integers. You would use an array to store integers, but how do you create the array if you don't know the size? Remember the size, you have to have it fixed as a constant. The size may change as you add or remove integers. To deal with this, your program needs to have the ability to allocate and release the memory for the integers on the fly. This can be accomplished using pointers. So we're going to look at the pointers now. Pointers is also known as pointer variables. They are the same. Pointers are declared to hold memory addresses as their values. Normally, a variable contains a data value, for example, integer, a floating point number, a character. However, a pointer contains the memory address of the variable that in turn contains the data value. So let's look at this diagram here. We have this variable count is an int with value 5. Int is stored in 4 bytes. So those are the 4 bytes. Now, what is the address for this int variable? That is right here. This is the address. Now, we're going to create a pointer. Is p count. So please note the pointer is same as a pointer variable. So this holds the address of a count. So the address using this ampersand, the address. So what is the data type of p-point? P-point is a pointer type, pointer of int. So using int asterisks. So this is asterisk here. Look, this is asterisk for pointer, and here ampersand for the address of the variable. So this address 0013FF60 now is stored for p-point. Similarly, status is a short, has 2 bytes. So this is the memory address 013FF64. That is here, p status is a pointer, store the address of status. A character, just 1 byte. This is the address 0013FF66. It is right here. This is the address, p letter. It's a pointer of character. The address is from this variable letter. Here is the object string. String has all the contents here. String object, this is the address for the string object 0013FF67. So this is the p string is the pointer for string. This at this s is ampersand. Here s is the address of that string. Now, we're going to see how you declare this pointer using this data type with asterisks. So this p point is a pointer of int type. P status is a point of short. P letter is a point of character. P string is a pointer of a string. We assign the address of an int variable to a point of int variable p count. So this ampersand reads as the address of count. This is also the operator. It's called the address operator. Now let's put all this in a program and see how this works here. And we have this count is int. And now I'm going to assign this the address of count to p count. So what is count? Count is 5. What is the address of count? So that gives you this value here. So let's run the program now. So now this depends on your system you're running. So what we're getting now is the address of count is now this 00CCFE60. So what is the p count? P count is the address. So you assign this, the address of count, to p count. So what is the value of count? You can now access it using this operator. It's the dereference operator. So this is you put the asterisk in front of this pointer variable. So what you're getting is the value that is stored in the variable pointed by p count. So it's the reference operator. So this is the operator. So we have now the operator here. Okay, now you can increase the count by 1 using count plus plus plus. You can also use this asterisk p count plus plus. So it's p asterisk p count is the same as refers to the same as count, the value. So this is the dereference operator. So dereference operator, it's indirection operator, and dereference means indirect reference. So this dereference the same as indirection. When a pointer is dereferenced, the value at the address stored in the pointer is retrieved. So you may pronounce asterisk p count as the value indirectly pointed by p count or simply pointed by p count. So that should be fine. Now we have used this asterisk in several different contexts. First, you can use it for multiplication. So this is the multiplication operator. And here you used it to declare a pointer variable. So this is to declare a pointer variable here, int asterisk. And this here is the dereference operator. So you get the contents pointed by p count indirectly. So don't worry about this. The compiler will automatically figure out from the context what is this asterisk is. Now, so one thing you need to know that you have this address of a variable is assigned to this pointer So the type must match. So this area is int, but this p point, this is double asterisk. So that has to be matched. It's not a match now. Int, both has to be int or both have to be the same double. Now, you cannot assign a pointer to an int variable. So that's not allowed. The pointer is address. It's just not the same type. So this is the int asterisk, and here's int, not the same. So please note that pointers are variables. So the naming convention for variables are applied to pointers. So far, we have used the pointers with the prefix p. However, it's impossible to enforce this convention. So soon you will realize that an array name is actually a pointer. So we will declare it when we use a pointer variable. Like local variables, a local pointer is assigned an arbitrary value if you don't initialize it. A pointer may be initialized to 0, which is a special value to indicate that the pointer points to nothing. Now, instead of using 0, it's better now using this keyword, null ptr. This is now new in C++11. Also, you can use this constant or uppercase null. That is a constant. It's the same as 0. And no point is the same as 0 too, but this using no pointer is better. So let's look at this figure here. We are going to see the assignment. What is the impact of assigning this py to px? X, py are pointers, point to x and y. So look, what is px? Holds the address of x. Py holds the address of y. So now let's do this assignment. Assign py to px. So you're gonna see the value here is copied here. And now both px and py holds the address of y. So now let's see what is this. Using this, we're gonna assign the value integrate value pointed by py and to the value into px. So this is the interaction. So this is going to have, you are going to assign 6 to 5. So because asterisk py is the value that is at the memory pointed by py. So that's here, same as asterisk px. All right, so let's look at this syntax here. In the book, we're going to use this to declare a pointer is put this asterisk right after the data type. Now, you're going to see in some other books, they may have this asterisk put in front of the variable. So both are fine. Actually, if you have just anywhere here between the data type and variable, you can put the asterisk. This is all equivalent. But to be consistent, I'm going to put it right here. So when you look at the int, you know, what is the int? No, it's the int asterisk. It's a pointer. All right. We're going to look at the, another thing here, later in the book, you will see that a function may return a pointer. It is more intuitive to write the function header as this. So now here's the function. What is function return? Oh, this is the type. What is this? This is the pointer type. rather than using this, it's kind of confusing. But there's one drawback of using this here, int. Right after this int, you put the asterisk here with this P1, P2. Now, most people will get confused. Now think about this P1, P2 are both pointers, but that's not the case. The line is unfortunately same as you have only this P1 is a pointer. P2 is int type, it's not a pointer type. So we recommend that you always declare pointer variables in single line like this for each. That is a very good beginning to introduce pointer basics. See you on the next video.